everyone, and welcome to our webinar on From Scan to Plan, Fast Track Your Network Planning. My name is Sam, and I'm the Global Head of Marketing at Ranplan Wireless, and we've asked our partner Amrex to join us today on our webinar. Before I hand over to the presenters, I have a bit of housekeeping for you. So you've all been placed on mute to minimize the disruption and to ensure we finish on time today. However, we still encourage you to ask questions throughout the presentation, and you can do this via the chat box, which hopefully you can see normally on the right-hand side of your screen, or if you're on the app, it might be at the top. We will answer as many questions as possible at the end of the webinar, but if we do run out of time, we will follow up on any unanswered questions via email. Just to let you know, this webinar is being recorded, and a recording will be sent out to you via email a few days after today. So keep an eye out for that in your inbox. It will come from Ranplan Wireless. I'm now going to pass you on to your presenters today, and I'm going to start with Martin.
Hello, everybody, and thank you so much for the introduction, Sam. It's a pleasure to be here with all of you today. My name is Martin Huber, and I am the CEO at MetaRoom by Amrex, representing a pioneering scanning solution based on smartphone LiDAR technology. Today, we are exploring a very exciting topic, and I can't wait to discuss it with you and Jan. Our solution is based on two connected products, MetaRoom Scan App and MetaRoom Studio. MetaRoom Scan App is an easy-to-use scan application, and MetaRoom Studio represents our powerful web app running in every browser. Inside MetaRoom Studio, you can share, enrich, and export your scans to the powerhouse of radio propagation calculation, Ranplan Wireless. We will also cover more of the advantages later. But today, you will see how fast and easy it is to create a fully parametric model that is perfect for later calculations. Now, Jan, can you tell us more about the webinar?
So hello, everyone. Thank you for joining this webinar today. Thank you, Martin, for introduction of the MetaRoom and Amrex company. So for those who do not know anything about Ranplan, let me introduce Ranplan very briefly from my side and my person. So my name is Jan Draha. I am head of solution engineering team and support team here at Ranplan. And what Ranplan is a pioneer of a tool, software, designing platform for design planning and optimizing the RF network, wireless network systems, not only for in-building solutions, but also from the urban outdoor perspective. So we are very unique in the market. We introduced first in the market 5G HeadNet design tool called Ranplan Professional, which is tool where designers are able to combine indoor and outdoor together and analyze signal propagation of the systems from the buildings to the air, to the outdoor scenario, and vice versa. We have a very rich research, and we are using research as our core of our solutions, of course, that helps us to react and improve our tools regularly. We are also first in the market with support of IFC format of the files, which is getting to be very popular, 3D format or format of the 3D buildings. It's a kind of a logic of BIM. And thanks to this capability, and also, of course, thanks to the great application of Amrex or MetaRoom, we even speeded up the process of the 3D building modeling, because this is usually the most consuming part of the complete design of the networks. So thanks to this application, where we are able to scan the buildings automatically by LiDAR and then export to the IFC format, Ranplan is able to import this IFC format to the tool and then start with the efficient and accurate RF design. So this is all from my side right now. let's get back to Martin, and he will demonstrate more how the meta room works and what all you can scan via their unique application.
Digital transformation is a key to success in many industries, and wireless network planning is no exception. This is why we established this partnership between Ranplan Wireless and MetaRoom. This collaboration is set to redefine the landscape of wireless network design, offering groundbreaking solutions that merge the precision of 3D modeling with the intelligence of AI. Let us guide you through this game-changing workflow today. So let's get started, huh? Everything we do here at MetaRoom starts with a LiDAR sensor. In recent years, every Apple iPhone Pro or iPad Pro has been equipped with such a sensor. To use MetaRoom, we simply go into the App Store and download MetaRoom. When this is finished, you can create an account. By the way, completely free without any limitations for 30 days. Now you can log in with your account and start scanning a room by clicking the Add Scan button. Start scanning by pointing your device's camera at the top edge of the wall. Recognition lines will appear on the screen. Just follow the instructions. Move your device up and down at a moderate speed, like when recording a video. Note that the white lines and boxes visible during the scanning process serve only as visual feedback, indicating the areas that have already been scanned. They are meant for orientation purposes only and do not reflect the final model. The completed 3D model, accessible in the Scan app or MetaRoom Studio after scanning, undergoes further optimization based on the captured data to reduce errors and enhance accuracy. Start walking around the room while keeping 2 to 3 meters to the closest wall while scanning. Keep pointing the device's camera at the walls and objects. Just walk through the room while you capture everything. A preview of the 3D model is visible at the bottom of the screen. Once you have captured your first room, click Stop. If you need to capture multiple rooms, scanning one room after the other is the best practice. You must follow the same procedure for scanning single room, only adding more scans of different rooms. To scan multiple rooms, click the Add Scan button. Start scanning the second room from a clear corner, capturing both floor and ceiling. Remember to keep a distance of 2 to 3 meters from walls and objects. Keep a moderate speed while scanning and walking around. Check the 3D room model at the bottom of the screen to ensure that all needed walls and objects are captured. Once the second room is fully scanned, keep scanning the next room. Follow the same steps as before. Keep adding room by room this way until you are finished. Then click Finish when you have covered all areas. The key distinction between a multi-room scan and a large space scan lies in the space's structure. A large space scan typically involves a vast open area with a minimal obstructions such as walls and spans over 100 square meters. This type of scan demands additional planning to ensure comprehensive coverage. Before you begin, plan how to divide the large space into sections, each approximately the size of a single room, about 100 square meters. This preliminary step is crucial for maintaining the manageability and quality of your scans. Position yourself at the starting point of your first designated section. Move in a larger circle and return to your starting point to close the loop. This movement supports the optimization process. Once you have scanned the first section, press the stop button to end the scan. Start the scan next section by using the endpoint of your first scan. This section tells the meta room app that you are continuing the scanning process in a new area of the large space. Repeat the scanning process for each section of the space, stopping between each partial scan before moving on the next. Once you have scanned all sections of the large space, perform a final review to ensure all areas have been included. Tap the Finish Scan button to complete the process. The MetaRoom app will then stitch the partial scans into a cohesive model of the large space. Now the whole 3D model is being calculated, and it can take from 1 to 10 minutes depending on the size of the scan. Let's go to MetaRoom Studio now. We can log in with the same credentials as in the app and go to the My Rooms tab. We will find the scan space and click on Export. Exactly this model can later be used inside Ranplan, but this is something Jan can explain way better than I can. Let's go into some tips for scanning success. If an object is not captured, attempt to scan it from various angles. Should that fail, mark it with a point of interest for later modification. The accuracy of the 3D model improves with better lighting. While scanning can proceed in low light, for optimal results, turn on as many lights as possible or open blinds to let in natural light. So this was the first part around capturing our space and export it. And now let's hand over this data to Jan, who will show us the radio propagation calculation on the scan we did together. Please, Jan, the stage is yours.
Thank you, Martin, for your great section. So I'm happy to announce that in Ranplan we have now one more way how to get a 3D model of the building automatically to the tool. The MRX engineering team has developed and improved their application for exporting the 3D building model to the IFC format, which is Industrial Foundation Class format. And this format is supported by Ranplan, so that we are able to import the LiDAR scanned model of the building very quickly to the Ranplan tools. We all should be able to see Ranplan Professional now, which is our highest version of Ranplan planning software. First, I will demonstrate the process of the import. Let me open the window of the process, then select the IFC file, and the 3D model of the building will be then extracted and imported to the tool automatically. I'm just changing the name of the building, which will be generated in the project. And I can also check the material, which is usually automatically associated with our predefined materials from our material database. But if needed, of course, I'm able to modify the material manually here during the import process. And here we are. So this is the floor layout design window where we are able to see all extracted details of the building coming from the LiDAR scan. Scan provides automatically detected windows, doors, and walls or the furniture. Doors are from wood, windows are logically from glass, walls get automatically type of the concrete material. I'm demonstrating now also the possibility of relocation of the imported elements or reconfiguration of the elements for their material, and users are even able to modify the length of the wall, for example, and other parameters per each selected object. But in most of cases, all should be automatic and users shouldn't change anything. So we are able to start with the network design and deploy our signal source elements to analyze signal propagation through this 3D model coming from LiDAR scan. So I'm placing now the access point of a Wi-Fi system. I need to configure Wi-Fi system here and then set the prediction. I will choose the standard coverage parameter of Wi-Fi, RSSI, define other parameters of the prediction, and then I will let the tool to analyze signal propagation via our full 3D multi-ray tracing engine called Maxwell. I will just run the process of propagation calculation, and then once the process is completed, I will be able to visualize the results. Maxwell engine provides the results of signal propagation in all directions, considering reflection, diffraction, and propagation of the signal through the materials. The heat map can very well present the effect of the different materials of building elements. It's displayed 1 meter above the ground of the floor, but that's of course customizable. And that was the first calculation, and now I would like to relocate the signal source and then recalculate. I will recalculate only the changes, which should be faster than the standard complete calculation, but users can decide for the force calculation and recalculate all from the beginning. Due to this logic, we are able to get the results of the calculation even faster. For another example, I would like to deploy now set of small cells of a 5G system. Of course, that can be private 5G system. We can talk also about public 5G. We are able to deploy sources inside the building, but also around the building, even in the outdoor scenario. We can then associate 3D model of the building with the outdoor contours from the outdoor scenario, and then activate HeadNet analysis and analyze the signal propagation from outdoor to indoor and vice versa. I'll choose here again the coverage KPI, which is SSRSR power for 5G systems, and to configure the parameters of the prediction, the transmitter selection, and also the targets. So I will calculate now in the full 3D mode, which means the Maxwell will provide me the results in all levels above the ground. We will have a great picture of the signal propagation and activate the signal visualization in all angles of the perspective. Users are able to also control a set of parameters related to the processing time of the prediction, such as the radius of antennas or resolution of the signal analysis, which can be very useful, especially in the cases where we have more complex 3D models of the buildings with a lot of floors and other details, plus a larger amount of antennas or other radiating elements. The propagation results can be then animated in the 3D view. Users are able to animate vertically, horizontally. We can activate building or signal for animation, or even combine both together and configure the animation exactly in the mode we need and we want to present. The different materials attenuation is evident in the colors. So we were able to see the import of one floor of the building from the MREX IFC format file. And of course, we are able to even scan multi-floor building by Amrex application and import the complete building. But here, I would like just to demonstrate quickly how we can even extend our one floor building for other floors, and then we can easily make copies of our imported 3D model of the floor and complete the multi-floor building. And the same also for the network design, which means I would like to copy the signal source elements, which are here 5G small cells, so that we will have antennas or small cells deployed on other floors of the building. For the recalculation, I will choose here the target mode by floor, which means the signal prediction will be visualized only in the specific level. In default, the heat map will be visualized 1 meter above the ground of each floor, so that the recalculation of the prediction should be a bit faster, and the process can be monitored in the task window, usually on the bottom of the screen. We can see the progress of the process in percentage. The effect of the signal propagation is calculated not only per each floor individually, but we also consider so-called cross-floor effect, where actually signal gets from one floor to others, and users are able to control also the amount of affected floors in the configuration of the propagation engine. So it's done, and now we are able to visualize the results. Let me rotate the building a bit in the 3D view. Look at the results from the different perspective. You can see also where the different transparency per each type of the material. Windows from glass are much more transparent, which can present more intuitive and realistic situation in the 3D view mode. And the last part of the standard planning process is surely proper reporting. So I would like to show you how we can generate the detailed reports of the situation. So now I would like to show you how we can generate the high resolution great reports of the 3D building imported from LiDAR scanned results by Amrex application, and how to save these reports, for example, in the very popular PDF format, or how to print them directly from the tool. I'm exporting the situation to the PDF format. I can choose which content I would like the tool to prepare for export. And after opening the PDF report, we are able to see how well the results of the project are presented. We are able to do zoom in, zoom out without any loss of the details. And such a PDF report can be easily shared with others without any needs of a license of the Ranplan tool. Of course, Ranplan users are able to extend this type of report by other general reports predefined in the reporting panel of our planning tool.
Okay, so that was all from my side for now. And now I believe we can get to questions, and we will try to answer as many as possible questions today.
So I do have a question here, which is probably best suited for Martin. How does the tool know where to connect separate scans of rooms to make a larger model?
Yeah, thanks for the question. So the app has a so-called world tracking. So if you do the first scan segment, that could be one room, and you stop this scan segment, and then you move outside this room and you go into a second room, and then start again a scan process. The app is capable of stitching these two scans together, as it will always have the global tracking. And it does this by searching for key points using the 2D cameras. So it's also necessary to not cover the cameras or not to put the phone into the pocket, because then the tracking is lost. If you imagine you go upstairs, then you can think about it. The app can basically count the stairs and also knows if you have switched the level in your building. So I hope this clarifies it.
That's great. Thank you. And Jan, this is a question for you. How long does the import to Ranplan take? Does this vary based on the project size?
Yeah, that's definitely a very relevant question. Of course, you know what, this, let's say, can be the second part of the complete process of the import. So even to Ranplan, we can get the 3D model of the building very quickly. It doesn't have to be only the model coming from a meta room, yeah, but even other models from IFC format can be quickly imported to the tool. What we also learned, by the way, IFC format is still something very new or relatively new in the market. Yeah, so it very much depends how it's modeled inside the format. And of course, for more complex buildings, the tool needs longer. That's a logic. But especially for buildings scanned by LiDAR coming from meta room, is a matter of seconds, maximum matter of minutes. Yeah, so the process in the tool, as you have seen, is actually monitored, or we can monitor the process. We can see the process in percentage, and then of course, based on what all we would like to, let's say, redefine or modify during the process, we need a few more maybe minutes. But overall, import from the IFC format coming from MetaRoom to the build to the Ranplan is a matter of few minutes maximum.
Yeah, absolutely. And Martin, I think you kind of covered off some of this, but could you answer this question for me? Are there any specific hardware requirements for conducting the LiDAR scanning with MetaRoom?
Yes, exactly. Thank you for the question. So everything we do is based on rear side LiDAR sensors. So it's a real depth measurement sensor that is available in Apple Pro devices, starting from iPhone 12 Pro and goes up to iPhone 15 Pro, but also works on iPad Pro starting from the year 2020.
Perfect, thank you. And again, Martin, can the app scan small outdoor scenarios like a small outdoor structure?
Yeah, it's a tough one. So typically everything about the logic the app builds up the model is starting from an interior perspective. So for example, if you go to an outdoor wall, also the outdoor wall will be recognized. Also windows will be recognized. But typically when at the end of the scan process, everything is stitched together, the app will think about it as an interior space. So maybe wrong rules could be applied. I have seen successful smaller outdoor scans, but it has been optimized and built for indoor.
Perfect, thank you. And Jan, which version of Ranplan do you need to use this IFC import?
Yeah, so you should have a minimalist 6.9 version. Yeah. Simply said, the version where we are able to import from IFC format. Yeah, so that should be 6.9 version. We very soon will introduce 7.0, which should come, I think, in a matter of months. Yeah, 1 month, which means you will be able to even find more options, not only this one, more new features there, but at least 6.9, if I'm correct. Yeah, but it's also good to say that actually we are still in touch with the Amarak's great team, and actually we have been developing and improving these capabilities. Yeah, so it depends also on the new hardware of iPhones, for example, iPads coming in the future. So of course this is about massive evolution. So once we have more options how to generate the building, how to detect the objects, we will try to implement it together with the Amarak's team, which is very, very promising for future.
Great, thank you. And again, Jan, how does Ranplan handle complex building structures or irregular shapes in the 3D model?
Yes, so in terms of the complex, if I can say difficult structures of the building, because of course in Ranplan we can design very I would say sophisticated systems, but for difficult scenarios, not only for a simple room, simple office structure or office structure buildings, right? So we can design public safety networks. We can be in mines. We can do detailed airports, tunnels, and so on. So of course it can be about very complex structures. In that case, I believe we are still a bit limited by LiDAR scan. Yeah, this is something we will be improving, of course, step by step. Right now, I believe we are ready for, let's say, standard buildings, standard type of rooms. But of course, hopefully, in near future, we will be able to consider even, let's say, inclined planes, more complicated walls and so on. And of course, it also depends on how far we can scan, how far the object can be from our iPhone, from our LiDAR scanning chip, let's say. Yeah. And it also depends, of course, on evaluation of hardware, of iPhones, iPads, and maybe in future also could be possible in Android types or phones of using Android. Yeah, so maybe Martin, you can also complete this answer.
Absolutely. Yeah. Thank you, Jan. I think you already mentioned the most important topic. So when we take a look at traditional, conventional 3D measurement space, then in the past, optics and laser has been the core setting technology of this ecosystem. Now, when it comes to MetaRoom running on smartphones with LiDAR, it's much more about AI and computer vision that generates these big improvements. And what we have seen when we started here in 2020, so this is 4 years ago, that also the level of detail and accuracy got better by a multiple of probably 4 to 5. So if you just look at the future and everything around this space looks very promising. So we believe that also due to Apple's work, but also our work in this space, this technology will become better and better, and it also already has become better a lot.
Thank you. And Martin, someone's asked, can you indicate roughly how long the scanning process takes? Can you give us a kind of an idea of an example?
Absolutely. You have all seen the case we had in the video. It's part here of our office. It's round about 400 square meters, and it took me 12 minutes to scan it. So typically we say for one room, it takes 1 to 2 minutes. If it's a longer corridor, maybe it's 2 to 3 minutes. But that's round about the numbers I have from my experience.
Perfect, thank you. And Jan, can Ranplan use a hybrid coverage combination of 5G and Wi-Fi, for instance?
Yes, absolutely. Yeah, so all what we demonstrated today was how to get quickly the 3D model of the building coming from LiDAR scan, right? But then you can use this model and this situation, this scenario for any of the systems we can design in Ranplan, and it's a well known that actually Ranplan is universal from the first frequency perspective, from the type of system perspective as well. So users, of course, can use this approach for Wi-Fi systems, public safety systems, 3G, 4G, 5G systems, LoRa, Sigfox systems. Simply said, they can create very quickly now a very nice 3D model of the building, and then continue with other, let's say, stages, sections of the planning process. And of course, everybody is learning. We are also learning how to use and utilize the latest features in the market, right? So hopefully we will be able to improve this area more very soon. But all is also about the feedback coming from our users. So of course, for those who are using our tool, feel free to get back to us, and then we will try to react. And we are looking forward to your feedback, right? So we can learn also from your experience, because of course it's good to indicate how long you need for each of the sections, but it very much depends how many rooms you would like to collect together through one scan, how many floors maybe, and so on, how many antennas you can deploy over your building. So that can be very complex situation. On the other side, what I can say, even the prediction, we are using Maxwell. We use normally Maxwell, which is full 3D ray tracing engine, which should provide you very nice, very accurate results. But this is not something which should work slowly over this scanned building. Yeah, so it works, I would say, very similarly as if you model it just manually. Yeah, we develop some new functionalities inside. So of course, the elements are imported sometimes as 3D elements, not as just one line walls, but 3D elements representing each wall. But it reacts great for signal propagation through these walls and these objects, and you can get the pictures of the signal propagation still very quickly, I would say.
Great. And I've got one more question, which is to Martin. Like, how accurate is the LiDAR scanning process in capturing the building details?
So when we use an actual device, so that would be an iPhone 15 Pro or an iPad Pro from last year, we come down to 5 to 3 centimeters plus minus from wall to wall. So if you add different scan segments, you can say that in every scan segment, we guarantee that you are below 5 centimeters in tolerance.
Brilliant. Oh, I've just had another question come in. Which is the best tool to measure on-site radio coverage that is not too expensive? Any comments, any suggestions?
Yeah, nice question. It's always balance, yeah. So very much depends what exactly you would like to design, how accurately you would like to design it. Yeah. So there are some other variants, maybe options in the market, but it's always the balance between usability and accuracy and even speed. Yeah, the processing time speed. Yeah. So of course, if you would like to design something very quickly with a relatively lower accuracy, something, so you would like to design some Wi-Fi systems quickly, of course maybe you can find some alternatives in the market. Of course, in Ranplan, from the RF design perspective, you can do that as well very quickly or relatively quickly. We have some nice features which can speed up the process. You don't have to be so precise. On the other side, the Ranplan tools are here also for very nice, precise, deep investigation of the situation, prediction of the signal propagation. And that's also the reason we would like to have a very nice and as a relatively very accurate 3D model of the buildings, which can be provided by LiDAR scan. Yeah, so even this resolution is great for tools who do not know the details of how to configure our Maxwell, for example. Our minimum resolution for indoor is 10 centimeters. Yeah, so we can start from 10 centimeters, and in default we calculate half of the meter. Yeah, resolution. So we can also configure some parameters for predictions, but because of course it depends on how large scenario you have, how detailed building you have, how many antennas you have, radius of antennas, and then also the resolution. All that is a mixture of parameters which have the effect on the processing time, and you must work practically, right? You don't want to recalculate something for ages or for a week, right? You need to do the design quickly. So we have also options, for example, to calculate on the changes, and then in the end, once you think everything is good, is done, is even optimized, then you can just recalculate everything from beginning with maybe even, I would say, stronger parameters and so on. So you can do a lot, but of course then it depends what exactly you would like to get. Yeah, if you underestimate the design, you will use some even maybe, I don't know, maybe even free of charge software, cloud version of planning software, who knows. You can do that, but then you can be in very big risk of misfunctionalities, some imperfections of the design. And once the design is installed with imperfections, you can imagine addition cost is huge, is dramatic. So it very much depends. If it's about your, let's say, home Wi-Fi, of course, you can try something what you find even online somewhere. Yeah, but if you would like to design something more precisely, Wi-Fi, pardon me, 5G systems, of course, IoT systems, or even low latency systems, for example, as the systems you need to rely on, that can be very risky if you choose something very simple for design.
To follow on from that, actually, they've asked, can we upload the radio coverage measuring results to Ranplan tool to retrain the simulation to get a bit more accurate result, I suppose?
Yeah, that's possible. And you know what, this is a very standard part of good planning tools. Yeah, not only in Ranplan, of course, but the user should be able to import measurement data. Yeah, because once you start, even in a Ranplan, if you start from if you create a new project from scratch, and if you don't have your specific template saved, which you can use at the beginning, if you start from default, of course, you are starting using default parameters of materials, default parameters of our propagation engine, and so on, and more, right? So then you can create everything, you can analyze the network, and you shouldn't be so far from reality, of course. Yeah, but it's coming from some, let's say, deep measurements of materials in chambers and so on. But sometimes it can happen that you have a little bit specific materials, or you are not sure about your building structure inside. So you can you complete it. You can even use LiDAR scan. Then you can get the building from LiDAR scan. But you know there is some difference of your material from some other area of Europe or even globally, yeah, where different materials of concrete or specific material of concrete is used. So then you can change it. You can change even any scanning element for materials. Yeah, you can change the materials of that element. You can do that, but you must have this material defined in the database. And there are more options. You can define it from your side, or you can import measurement data, and then you can run the calibration. And the tool will help you to calibrate parameters all together or individually. You can choose if you'd like to calibrate only one material, more materials, if you like to calibrate also the engine parameters and so on. And then this all can allow you to get even closer to the real situation. So for example, if you have your work test inside the building on one floor, you will be able to get a good picture there by measurement data, and then you will calibrate complete building. So of course that should positively have some impact or effect to the complete building and improve your analysis through all the projects. So this is one of standard methods how to get even closer to the real situation.
That's great, thank you. Yeah. So that's all the questions I have at the moment. Obviously, if anyone does have any further questions for Martin or Jan after the webinar, their email addresses are on the screen at the moment, but obviously we'll be sending out a recording of this webinar, and you can follow up via that email as well if you have any other questions. We hope you've enjoyed today's session, and thank you very much, Martin and Jan, for presenting today. And we hope you join us on our next webinar.
Thank you.
Thank you. Thank you, Sam. Thank you all.